So in the previous lecture, we were talking about the static characteristics. Static characteristics का मतलब था कि जब हमें कोई भी static measurements करने हैं जो कि constant हैं time के respect में या बहुत ही slow moving values हैं, okay, then in that case, whenever we have to measure, make some measurement, what are the desired characteristics that your measurement system should have? Okay, now the point is that if you are making a dynamic measurement का मतलब होता है कि continuously changing with time. If you have a signal, अभी तक हम suppose कोई एक value किसी एक time instant पर measure कर रहे थे या कोई नॉन डायनेमिक चीज है जैसे लेंथ हो गई या इस तरह का कुछ हम मेजर कर रहे थे, दैट वाज ऑल स्टैटिक कैरेक्टरिस्टिक्स. But suppose we are talking of measuring or controlling the speed, okay, or we are talking about the level of, suppose, a tank where continuously there is an inflow and the outflow. So these are processes, or maybe you have a flow in a pipe which you have to measure. So all these are basically dynamic changes, or you have to measure a voltage in a process which is in terms of a continuous signal. These are all dynamic changes, or you can say dynamic signals that we want to measure. In such cases, there are certain characteristics which are very important for your system to have. They are termed as dynamic characteristics. So in today's session, we are going to talk about what are the dynamic characteristics that a system should have. And also we are going to talk something about something called time response. Okay, time response of a system means how the output is varying with respect to time of a given system. Okay, and how do we analyze that output? उस output के help से हम कितने parameters judge कर सकते हैं, system के बारे में क्या information हमें मिल सकती है. Okay, and how do we what terminologies we use when we talk of the output, that all comes under time response. Okay, so, system response, or you can say time response. So that part also, some introduction we are going to talk in today's session. So the set of criteria that are defined for the instruments which change rapidly with time is called dynamic characteristics. That means the set of instruments which are used for the signals or the measurements which are changing rapidly with time. For that, the criteria that should meet, that the instrument should have, that is called dynamic characteristics. The most important ones that we are going to talk about over here, that is speed of response, measuring lag, fidelity, and the dynamic error. Now, speed of response means what? Speed of response means how rapidly the system can respond to any change that is taking place in the measured quantity. Okay, so it is defined as the rapidity with which the measurement system responds to changes in the measured quantity. Now, if there is speed of response को हम कैसे measure कर सकते हैं, whether it is fast or whether it is slow, that can be measured with the help of measuring lag. Okay, now it is the retardation or the delay in the response of the measurement system towards the changes in the measured quantity. Measuring lag usually picture में कब आता है, जब हमारे पास कोई remote measurements हो रहे होते हैं. ठीक है, for example, if I am measuring something in the field but it is being displayed somewhere in the office at some distance, at some physical distance, in that case जब तक हमारा signal travel करेगा for different stages, amplification के लिए या कोई भी modulation हमें उसमें करनी है, कोई manipulation करनी है, जब तक वो finally display पे आता है, जब तक वो finally हमें value मिलती है, तब तक क्या है, there is slight delay because of that transmission that is taking place. That difference between, for example, जब हमें time instant t is equal to 2 seconds पर जो value दिख रही है, वो एक्चुअली में सिस्टम की वैल्यू होगी सपोज एट टाइम t is equal to 0.5 seconds, क्योंकि उसमें थोड़ा सा ट्रांसपोर्टेशन लैग है कि जितने देर उसको सिग्नल को ट्रांसमिट होने में लगता है उतना सा लैग आएगा सिस्टम में फॉर बिटवीन द इनपुट एंड द आउटपुट वैल्यूज. दैट इज कॉल्ड मेजरिंग लैग. ओके, सो दैट अगेन this should be minimum in the system. Ideally it should be 0. और अगर measuring lag 0 होगा तो speed of response automatically fast हो जाएगा. If there is some measuring lag, the speed of response is going to become slow. Then there is something called dynamic error. It is the difference between the true value of the quantity changing with time and the value indicated by the measuring system if no static error is assumed. We can also call it as measurement error. So dynamic error again is the, you can call it as an error graph with respect to time. Okay, जैसे for example earlier हमने जो static errors की बात करी थी, suppose there is a +5 का error है आपके इंस्ट्रूमेंट में, दैट इज अ स्टैटिक एरर, कि जब भी आप कोई आउटपुट लेते हो यू सिंपली सब्ट्रैक्ट -5 फ्रॉम दैट एंड यू विल गेट द एक्चुअल वैल्यू. ये क्या है? ये स्टैटिक एरर है. दैट वन कांस्टेंट वैल्यू सपोज गेट्स एडेड टू द मेजरमेंट, एट द आउटपुट यू कैन जस्ट सब्ट्रैक्ट इट एंड गेट द वैल्यू. डायनामिक एरर का मतलब होता है कि एरर भी टाइम के साथ चेंज हो सकता है. ओके जैसे हमारा आउटपुट रैपिडली चेंजिंग है, उस हिसाब से हमारा एरर भी रैपिडली चेंज हो सकता है टाइम के साथ. दिस काइंड ऑफ एन एरर इन द सिस्टम इज एक्चुअली कॉल्ड डायनेमिक एरर. इस तरह का जो एरर होता है इसे हम किसी एक वैल्यू या किसी एक रेंज से नहीं जज करते हैं, हम इसका एक टाइम पीरियड के लिए ग्राफिकल प्लॉट लेकर and then we try to analyze that what kind of an error is coming in this system and how do we remove this error. So this is actually, you can also call it as measurement error, or you can also call it as dynamic error. Then we have something called fidelity. Fidelity is defined as the degree to which the measurement system indicates changes in the measured quantity without any dynamic error. So again, fidelity relates to dynamic error. If dynamic error is very, very less, we have high fidelity, or you can say the confidence factor is high on the instrument. If you talk in layman language, we can say it is the confidence factor that you have on the system, that it is going to give you a measurement without dynamic error. Low fidelity means if there is high dynamic error. High fidelity means that there is low dynamic error and the system can actually give you the measured quantities very, very close to the true value over a period of time. Continuously जब तक हमें सिग्नल मिल रहा है, उस पूरे टाइम ड्यूरेशन के लिए अगर हमारा डायनामिक एरर 0 है या वेरी लो है, that means the system has high fidelity, or you can say the confidence factor of the system is very high. Now, there is an important thing that we need to study, which is called time response. So next important thing that we need to study, that we need to understand while designing any system, because all these things when we are talking about, we are talking about the complete system. When we are talking of system, measurement system, you all know कि उसमें हमारे पास amplifiers, manipulators, transmitters, receivers, display devices, okay, indicators, बहुत सारी चीजें आ जाती हैं. So collectively, it is not just one measuring device, it is actually a measuring system. तो जब पूरा system बन जाता है, तो system जब बनेगा, तो time response एक बहुत important factor होता है उसमें. ठीक है? Now time response of the system is the output which is a function of time when the input is applied. जब भी हम किसी सिस्टम को एक इनपुट देते हैं, तो आउटपुट पर हमें क्या सिग्नल मिलता है, क्या इंफॉर्मेशन मिलती है, उसको जब हम टाइम के साथ प्लॉट करते हैं, दैट graph is called actually the time response. On your screen you can see there are two examples. Okay, these are time responses. एक आप रेड कलर का ग्राफ देख रहे हो कि जैसे ही हमने सपोज कोई इनपुट पे सिग्नल दिया, तो आउटपुट पे क्या होगा, धीरे 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 सिग्नल जो पहले एट रेस्ट था, आउटपुट पे सिग्नल धीरे धीरे राइज करना शुरू करेगा. ओके, इट गोज अप टू सम पीक वैल्यू, then comes down. So you can see there are certain oscillations in the red colored graph, and finally it gets settled to one particular value. और दूसरा, if you see the black colored graph just below that in the second figure, that is a gradually rising graph. Okay, so these are different types of responses that we might get for any particular system. और इस response को हम दो parts में divide करते हैं. Listen to this very carefully. Whenever you give an input to the system, Okay, the output that we are getting over a period of time is actually called time response. And this time response always consists of two parts. One is transient response, one is steady state response. Transient response का मतलब response का वो section जब जीरो से start होकर final value के बीच में the system is actually transmoving from the initial point to the final point. जैसे for example, whenever you switch on a fan, basically what you are doing is you switch on the, when you switch, put the switch on, आपने एक वोल्टेज दिया मोटर को, फैन में मोटर लगी हुई है, ओके, एंड दैट्स इट स्टार्ट्स रोटेटिंग. Does it so happen that as soon as you switch it on, at the same instant the fan starts moving at 5? It does not happen like that. What happens is when you switch it on, धीरे धीरे फैन धीरे धीरे पहले मूव करना शुरू करता है, एंड ग्रेजुअली इट स्टार्ट्स इंक्रीजिंग द स्पीड एंड इट मूव्स अप टू दैट पर्टिकुलर वैल्यू ऑफ स्पीड जो आपने इनपुट पे दी थी. जैसे कि रेगुलेटर अगर आपने 4 पे किया है, व्हेन यू पुट इट ऑन, स्विच ऑन करोगे आप, ग्रेजुअली वो धीरे धीरे स्पीड से शुरू होगा एंड फाइनली आफ्टर अ फ्यू सेकेंड्स इट रीचेस अ फाइनल स्पीड ऑफ 4. ठीक है, दिस एक्चुअली अगर हम इसको ग्राफिकली रिप्रेजेंट करना चाहें, द ब्लैक कलर्ड ग्राफ दैट यू सी इन द बिलो फिगर, दिस रिप्रेजेंट्स हाउ योर फैन एक्चुअली स्टार्ट्स मूविंग, द आउटपुट ऑफ द फैन. कि हमने इनपुट पर उसको एक वैल्यू दी 4, जो हॉरिजॉन्टल लाइन आपको दिखाई दे रही है इस वाले, सी द पॉइंटर वेयर आई एम मूविंग ऑन दिस पर्टिकुलर ग्राफ, ये जो डॉटेड लाइन आपको दिख रही है हॉरिजॉन्टल, दिस इंडिकेट्स द वैल्यू दैट वी हैव गिवन एट द इनपुट which we actually want to achieve. Suppose this is 4. Now when you give this value, that means when you put the switch on, your fan motor from 0, that means the speed, it is at rest, so speed is 0. As soon as you give it some voltage, it will start rising from here and gradually rising, the speed will reach the exact value of 4 and then it will become constant at that value. Okay, so this is what this is, time response of the system, or you can say the, for example the fan system. अब इसमें ये जो फर्स्ट पार्ट आपको दिखाई दे रहा है, जब वो 0 से फाइनल वैल्यू के बीच में मूव कर रहा है, ना तो फाइनल वैल्यू अचीव हुई है लेकिन वो रेस्ट पर भी नहीं है, तो ये जो बीच का पार्ट होता है, दिस इज कॉल्ड ट्रांजिएंट स्टेट. ओके, दिस इज कॉल्ड ट्रांजिएंट स्टेट. इसका मतलब जब फैन को आपने ऑन किया, जब वो 0 से जस्ट धीरे से स्टार्ट करता है मूव करना, और जब वो 4 पे पहुंचा, उससे जस्ट एक टाइम इंस्टेंट पहले तक का जो ये रिस्पॉन्स है, उसे हम ट्रांजिएंट रिस्पॉन्स बोलते हैं. और जब वो फाइनल वैल्यू को अचीव कर लेता है, फाइनल वैल्यू को अचीव करने के बाद वो एक कांस्टेंट वैल्यू पर इट गोज ऑन वर्किंग, उस पार्ट को हम बोलते हैं स्टेडी स्टेट रिस्पॉन्स. स्टेडी स्टेट मीन्स it has come to a fixed point now. Transient means it is continuously changing with time. So this is one example. अब कोई system ऐसा भी हो सकता है कि जिसमें it goes on fluctuating. अब just let me give you a hypothetical example कि कोई एक मोटर आपने ऑन करी, मोटर की स्पीड पहले बहुत हाई चली गई, ठीक है, फिर क्या हुआ, वो कुछ धीरे धीरे उसने मोटर स्लो डाउन हुई, फिर कुछ हाई चली गई, फिर धीरे धीरे स्लो, like this slow high करते करते finally it actually settles to one particular speed value. This is just I'm giving you a hypothetical example that if ऐसा होगा तो ये जो रेड कलर का ग्राफ आपको दिख रहा है, तो उस केस में ऐसा आउटपुट आपको मिलेगा. ठीक है, सो इन दिस केस यू कैन सी कि जब तक ये ऑसिलेशंस आ रही हैं, ये पार्ट जो है, this is called the transient part of the response, and once these oscillations die down and what happens, you have a constant output, constant value पर जाकर settle हो गया है आपका output, then we call this as steady state response. That means your response has now achieved a steady state value. Okay, now the steady state usually from application to application it depends. Usually क्या होता है कि जो हमारी exact value है उसके 2% प्लस माइनस बैंड के अंदर जब ये आ जाता है रिस्पॉन्स, हम उसको स्टेडी स्टेट एज्यूम कर लेते हैं. इन सम एप्लीकेशंस इट कैन बी अ 2% बैंड, सर्टेन एप्लीकेशंस इट कैन बी अ 4% बैंड, मैक्सिमम अप टू 5% वी टेक. ओके, सो इफ फाइनल जो वैल्यू है इसके ऊपर और नीचे ±5% मैक्सिमम तक अंदर अगर आ गया है आपका रिस्पॉन्स, एंड इट डज नॉट गो आउट ओके इन एनी फ्यूचर टाइम इंस्टेंट, तब हम कहते हैं कि सिस्टम ने एक स्टेडी स्टेट वैल्यू को अचीव कर लिया है. सो वंस अगेन लेट मी सम अप. Whenever you are giving an input to any system, which might be a constant value, which might be varying with respect to time, whatever output we get, when we plot that output with respect to time, this function that we are getting is actually called time response. This time response of a system will always consist of two parts. First is the transient part, and second is the steady state part. Transient part means the output is still not at one fixed value. It is changing. It might be changing in an increasing manner, like you can see in this black colored example, or it might be changing in a fluctuating manner, giving me oscillations. Any kind of change might be there. It might be exponentially decreasing also. Anything can be there. Okay, so there is, till the time there is some fluctuation taking place in the response, we call that part as a transient response. And gradually, as the time goes by, when my system achieves one constant value, one steady value, I say that my system has achieved steady state response. So this total time response of any system can be represented as time response plus steady state response. So CT is the time response, is equal to, okay, C transient. This small t indicates transient, and over here small s, it indicates steady state. So actually the complete time response of the system is the combination, or you can say the addition of the transient response as well as the steady state response. So now when we are talking of response, like I had told you earlier also, that whenever we design any system in the practicals, we had seen, we had talked when we were talking about function generator, we had discussed this thing. Whenever we are designing any system, any electronic circuitry, and we want to check whether the system is performing as per our requirement or not, the first step that we do is we give some standard signals as an input, and then we check whether the output is coming as per what we had predicted or not. Okay, so the measurement system may be subjected to any type of input. The study of dynamic behavior of measurement systems, certain standard signals are employed for which the mathematical equations have already been developed. So कुछ standard signals होते हैं जिनका mathematical functioning हमें पता है. ओके और हमें ये मालूम होता है कि फॉर एग्जांपल अगर इस सिस्टम को मैंने इंटीग्रेटर से पास करना है, तो इस पर्टिकुलर मैथमेटिकल एक्सप्रेशन को मैं इंटीग्रेट करके आई कैन प्रिडिक्ट व्हाट द आउटपुट शुड बी. इफ आई एम गेटिंग द सेम आउटपुट, दैट मींस द सर्किट दैट आई हैव डिजाइंड फॉर एन इंटीग्रेटर इज करेक्ट. if that is not, if I'm not getting that, then that means the circuit that I have designed is not correct. Okay, so these are called test signals, or you can say these are called standard signals. And the standard signals are step input, ramp input, parabolic, impulse. These are just some of these. You can also use sine inputs. Okay, sometimes even cos inputs can be used. These are some standard signals. Okay, mostly what we use is an impulse input. Now these signals probably you must have already studied. Even in +1, +2 physics, we study usually these signals. Impulse means at time t is equal to 0, there is some magnitude, and then it is all 0. There is no magnitude. Sudden impulse. Step input means for time t greater than 0, there is some constant value. When I give that constant value as 1, I can call it a unit step. If suppose I can give 5, I can give 10, that is just a step input. That means some constant value at time t greater than 0. Or I might use a ramp input. Ramp input is when the input is increasing with time. Okay, so your output is actually some constant a multiplied by t. Okay, if again a is 1, then I can give it the name as unit ramp. So these are basic signals. These are standard signals. What you need to remember is what are the mathematical expressions of these. This you have to learn by heart. And what is the Laplace of this? Laplace also, I'm sure you must have studied at +2 level. So you must be aware what Laplace transform is. So what you need to do is these standard signals, their mathematical expression and the corresponding Laplace you should remember for the exam. Okay, so these are some basic test signals we have. Other than these also you can have like sine wave, you can have parabolic wave, you can have, these are some simple test signals. Now what is the concept behind why only these signals? That also let me tell you. Because it is observed that most of the practical signals that you get in the industry or maybe in the field, of course they might be a mixed up signal. Okay, some part might be constant, some part might be varying. Okay, real-time signals are usually like that. So it is observed that with the help of various mathematical tools, like we have transforms, Fourier transforms and all. So with the help of these kind of tools, most of the real-time field signals can actually be represented as a combination of some of these standard signals. यानी कि फील्ड में जितने भी तरीके के सिग्नल्स होते हैं उन्हें हम इन टेस्ट सिग्नल के किसी ना किसी कॉम्बिनेशन में मैथमेटिकली रिप्रेजेंट कर सकते हैं. Okay, this particular thing comes from the maths domain, so we are just taking advantage of the things that have been developed over there already. So that is why we have developed these test signals, that agar hamara signal in test signals ke liye it is giving us the desired output, it is expected that for any real time live signal coming from the field, it will behave as expected. So on that basis, we have actually selected these certain signals, which we call as standard signals, or we can also call them as test signals. Now, another important property is order of the system. Order of the system का मतलब होता है कि जब हम input और output की expression लिखते हैं, what is the highest level of derivative being used in that expression? Once again, I'm telling you, whenever we are writing the input and the output expression of any system, mathematical expression, उसमें highest order derivative का क्या है, that decides the order of the system. For example, on your screen you can see there is a simple potentiometer that I have, जिससे कि voltage divide हो रही है. Input पे हमने voltage लगाई VR. If I have to write the expression for the output voltage, it is simply VR multiplied by x divided by xm. xm पूरे पोटेंशियोमीटर की लेंथ है और x उतना लेंथ है जहां पर हमने उसका मूवेबल टैप को लगाए रखा है. सो अगर आप इस एक्सप्रेशन को देखो, इसमें कोई भी डिफरेंशियल इक्वेशन नहीं बनती है. There is no derivative involved in this expression. So this is a zero order system. Okay, this is a zero order system. That means there is no derivative involved in this expression. Okay, another possibility could be, suppose I have an RC circuit. Now, if I have this RC circuit, I want to find out the mathematical model of this. Mathematical model का मतलब input और output के मैं expressions बनाती हूँ. So I get some expression for V input and some expression for V output. Now there is a concept called transfer function. Transfer function में हम क्या करते हैं, हमने V input का expression लिखा, V output का expression लिखा, हम इन दोनों एक्सप्रेशन का लाप्लास ट्रांसफॉर्म निकालेंगे और इनको आपस में डिवाइड कर देते हैं. Once again, I will repeat. Whenever we want to write the system in terms of mathematical form, what do? We find out something called as transfer function. Transfer function basically क्या होता है? We write the expression for input, we write the expression for output, take the Laplace of these two and divide the output by input. तो जब आप ये परफॉर्म करोगे, आपको एक्सप्रेशन V नॉट अपॉन वी आई के टर्म्स में मिलेगा जब मैं आउटपुट को इनपुट से डिवाइड करूंगी. दिस एक्सप्रेशन, बिकॉज इट इज इन टर्म्स ऑफ लाप्लास, द एक्सप्रेशन दैट यू आर गोइंग टू गेट इज इन टर्म्स ऑफ S, and this S indicates this function that you have got, V naught upon Vi is equal to 1 plus 1 upon 1 plus S into CR. इस तरह का जो एक्सप्रेशन आता है इसे हम ट्रांसफर फंक्शन कहते हैं. Okay, if you have to define it, you can define it as the ratio of Laplace of output to the Laplace of input. यानी कि आउटपुट का एक्सप्रेशन लिखा, इनपुट का एक्सप्रेशन लिखा, दोनों का लाप्लास निकाला और आउटपुट को इनपुट से डिवाइड किया. तो जो रिजल्टेंट एक्सप्रेशन हमारे पास आता है, ये एक्सप्रेशन होता है रेशियो ऑफ लाप्लास ऑफ आउटपुट टू द लाप्लास ऑफ इनपुट। इसको जब हम सिंप्लीफाई करके कुछ ऐसा एक्सप्रेशन निकालते हैं विच विल ऑलवेज बी इन टर्म्स ऑफ एस, दिस इज कॉल्ड एज द ट्रांसफर फंक्शन। नाउ द ब्यूटी ऑफ दिस इज, जितने आपके इक्वेशन में डेरिवेटिव के टर्म्स होंगे उतने ऑर्डर का एस आपके लाप्लास ट्रांसफॉर्म के बाद आएगा। जैसे फॉर एग्जांपल इन दिस एक्सप्रेशन यू हैव अ सिंगल एस, you can write this as s to the power 1. This particular system is actually a first order system. If you see the original this system, इसमें क्या है, इसका आप अगर लाप्लास लेना भी चाहोगे, because there is no time dependent term in this, there won't be any s coming in this picture, so that means there is no s, that's zero order. Okay, but when you have an RC circuit, इसको अगर आप सॉल्व करोगे, इवन व्हेन यू वांट टू सॉल्व इट इन टर्म्स ऑफ टाइम, तो क्या होगा, इस इंटीग्रेशन को सॉल्व करने के लिए यू विल यू टेक इट इनटू डेरिवेटिव टर्म। ओके, v का डेरिवेटिव आ जाएगा इसमें, एंड फर्स्ट ऑर्डर डेरिवेटिव विल कम व्हेन यू विल ट्राई टू सॉल्व दीज एक्सप्रेशंस। सो अगर हम इस पर्टिकुलर सिस्टम को टाइम के टर्म्स में सॉल्व करेंगे तो डेरिवेटिव का फर्स्ट ऑर्डर आएगा, विच इंडिकेट्स दैट दिस इज द फर्स्ट ऑर्डर सिस्टम। और अगर हम इस सिस्टम को ट्रांसफर फंक्शन में कन्वर्ट कर लेते हैं, यानी कि लाप्लास ट्रांसफॉर्म अप्लाई करके उसका ट्रांसफर फंक्शन निकालते हैं, तब क्या होगा, s की जो पावर होगी डिनोमिनेटर में, दैट विल गिव यू द ऑर्डर ऑफ द सिस्टम। ओके, रिमेंबर द पावर ऑफ s, दैट इज द हाईएस्ट पावर ऑफ s in the denominator of the transfer function gives you the order of this particular system. तो जब हमने इसको सॉल्व किया था, इसकी जो डिनोमिनेटर एक्सप्रेशन है उसमें s to the power 1 आया, so this RC circuit is actually called a first order system.